So, what'd you guys get for number 1? Phone's away, earbuds out, let's go. Miss Pounds, what'd you get for number 1?
148.
Is that what everybody got? Annie, is that what you got? You got what? 149? What'd you get, Grace? Okay, I think you just missed the one on the couch, because that's what we had in first. All right, number 2. Randall, what'd you get? Hank, what'd you get?
The first term was 37.
Okay, so the first term is 37. Okay. Then what did we find for the next 4 terms? What did you get find?
93, 107, 121,
121 and then 135. Is that what everybody got? Okay. All right, for the last one. Oops. What'd you guys get for the last one? Chase, what'd you find? No? Oh, you weren't here yesterday, were you? Annie, did you get the last one? Whoops. Say what? Yeah, negative 16. How'd you find that? Did anybody figure, Erin, did you figure this one out? Okay. All right. That's why I asked, because I wanted to go over how we can do this. So you can use your formula, okay? But honestly, the easiest way to do it is think about what's the difference from negative 10 to 14? Right? And we know that the common difference is the exact same everything. So that means I went from here, I went 1 space, 2 term, 3 term, 4 terms. If I divide by 4, that gives me 6 as my common difference. Does that make sense? Kayla, where did I lose you? Okay, so think about like from a number line standpoint. Okay, I'm at negative 10, here's 0, and here's 14. Okay, from here to 0, I moved 10 spaces. From 0 to 14, I moved 14 spaces. So the total between the two is going to be the 24. Yeah? Awesome. Okay, so that makes 6 as my common difference. So I subtracted 6 since it was prior, and then if I add 6, 2 plus 6 is going to give me 8, and 8 plus 6 gives me the 14. Good? Okay, so what's the difference between 58 and negative 8? Well, if we think about negative 8 So I'm 8 spaces and 58, so that's going to give me 66. You're good. Okay, and I'm going to have 1, 2, 3 spaces. So that means my difference is going to be 22, except I'm going down. So that makes my difference a negative 22. And so 58 minus 22 is going to give me 36. Minus 22 is going to give me 14. 14 minus 22 gives me negative 8, so I'm good on that. And so negative 8 and negative 22 gives me negative 30. And since I'm going, but now I'm going positive, so that would give me 80. Does that make sense? Good on those? Alrighty, then let us talk about some sequences and series then. Actually, today is the 3rd, 4th. Tuesday. Let's start with that. I know it's Tuesday. That's about where I'm at today. Okay, so yesterday we talked about sequences, okay? And so if we have basically a list, it's a sequence. Agreed? Okay. If you have those same lists, but you're adding them, that's called a series of the terms. Okay? And when you actually take all the numbers and add them up, that's called a sum of the sequence. There's 2 ways you can designate, hey, this is the sum of the sequence. And we're going to use S to the n, but there's another, it looks like that. When you get into pre-calc next year and calculus and stuff, you're going to use that designation. That means sum too. Okay? That's the official Greek math symbol. Okay? So, what's the difference between a sequence and a series? What are we doing when we have a sequence? If this is my sequence and this is my series, what's the difference between them? Jake?
And the series we have.
Yeah, so the sequence, it's just the list. It's just, hey, here are the numbers. But when you have a series, it's the actual sum or addition. You're going to have addition signs. And when you have the list, you just have the commas. Okay, so let's kind of review what we did yesterday, just to make sure we're kind of good on this stuff. So we know that if it's a sequence, it's an ordered list of numbers, and the difference is constant. That's the key thing. We also know that they are written as a list, and that every value in that list is called the term, and the difference between those terms is called the common difference. And we have an unknown term that we can use, this handy dandy formula. Find all sorts of info on. Good? All right, so if I have this sequence and I want to find the 100th term, what do I want to do? I use this formula, right? Okay, I'm looking for the 100th term. What's my a to the first? What's my a1? What'd you say, Grace? 5, perfect. What's the n gonna be? Allie, what's my n? Yep. And then what's my D? Mary, what's D? Yeah, that's exactly what it is. Common difference, perfect. So what is my common difference for this series? Or I mean, this sequence, sorry, wrong word. Yeah, 3, because I have a difference of 3 between each. Perfect. Alrighty, so I can plug and chug now. So a to the 100th is equal to 5 plus 100 minus 1 times 3. And when I multiply, I'm going to get 300 minus 3. And add them all up, I'm going to get that the 100th term in my list is 302. Where'd I get what? Because I have to distribute. So 3 times 100 and then 3 times 1. Because I could have done 100 minus 1 and then had 99 and then 99 times 3, but I can't do that in my head. So I went ahead, but I know 100 times 3 is 300 and 1 times 3, and then I can do it in my head. Choice is either way is fine. Everybody with me? All right, so let's talk about some series. Series. I can't write today for some reason. It's really weird. Okay, so the definition is that it's the actual sum. Okay, so Annie, give me a number. Okay, and Hayden, give me another number.
6.
Okay, so what's my common difference going to be? Yeah, so now I have a difference of 1. Okay, if I was a sequence, I would have written it as 5, 6, 7, 8, but since I'm a sum, I write it as an addition. Okay? Because that's the part that we actually really want to know about. That's the part that's going to help us solving stuff out. So, however, if I had a great big long series, it would be a pain to have to sit there and do 5 plus 6 plus 7 plus 8. So we have this handy dandy formula. Okay? So the S of n is going to be, stands for the sum of the nth term Okay, so what's A1? It's the same thing. What's A1 stand for? What's A1's? Wow, what a yawn. That was a good one. What's A1 stand for? Yeah, my first term. And what's the nth term stand for? Any term, right? It's just whatever term you're looking for, just like yesterday. And then what's n represent? Ryan, what do you think? No. If I have like a to the 11th, that means I'm not a to the first, a to the 11th. That means I'm in the 11th position, right? Okay, so the n is basically going to be the term number or position in the list. Okay, good so far? All right, so we're going to use the formula and find the sum of the first 15 terms of the series. Okay, so I've got this handy dandy formula. I'm looking for the sum. I need to know what my n is. What's n? If I'm looking for the first 15 terms of the series. Matthew, what's n going to be there? What? Huh? No, I'm looking for the first 15 terms of this series. If n represents the term or position? Grace, what do you think? Yeah, that makes n going to be the 15, because that means I need 15 terms. I'm using that position of the series. Okay? So I have 15 divided by 2. What's A1? What's my very first term? Jordan, say that louder. 5. And then a to the 15th is going to be what? Oh. That's okay. I was not looking at that either, but good call. How can we find what a to the 15th is? Thank you, sir. How do you find a specific term number in a sequence? Do what we did yesterday. Use this formula to find the A15. Okay, so that means that a to the 15th is going to be 5 plus 15 minus 1. And who said my difference before? What's the difference between all of them? What's my common difference? 8, absolutely. So if I plug and chug, come on calculator, I'm going to get 5 plus 14 times 8. So now I know the 8 to the 15th is 117. Did I do that right?
I think it's
14 times 8 is plus 5. What?
Instead of a 5/8.
Oh, because I picked up my 5 again. Okay, much better. All right, so it was 114, right? Yeah, that makes sense. So 114, awesome. So now I can correct all myself. Now I can plug and chug. So 15 halves times 116 by 2 times 116 gives me that my 15th term was going to be 870. Okay? All right, so hardest part sometimes is figuring out like which formula to use. Okay? So, if I'm going to use this sequence to complete the following and write the nth term formula. Okay, so which one do I want to use? First equation or second equation if I'm using a sequence? The first. It's a sequence and it has commas. So that means I'm going to use a to the n is equal to a1 plus n minus 1 times my common difference. And if it says just to write the nth formula, that means simplify it. Just get the rule for this particular sequence. So I'm just looking for the a to the n. I'm going to just keep that there. And I know that my initial term is 26. And keeping my n, because I'm making it for anyone that any number I want. And what's my common difference? Is it a positive 13 or negative 13? Negative 13, perfect. Okay, let's plug and chug. So a to the nth is 26 plus whatever term I'm looking for minus the first one times negative 13. Everybody with me? Okay, so let's distribute. And so I'm going to have 26 minus 13n plus 13. Good? All right, when I combine all my like terms, for this particular series, that's going to be my rule. That means I can use it to find any term that I got in any of that sequence. Okay? This is also, when you have it simplified like that, it's sometimes called an explicit formula. Just FYI. All right, so now I have a formula. Let's find the 17th term. So I'm going to have negative 13 times my 17 plus my 39. So that's negative 21 plus 39. So the 17th term in the line is negative 182. God bless you. Good? Okay. Now this next one says find the first term in a sequence. So that means I'm using which equation? What do you guys think? Why? The first one's for sequences. The second one's for sums. If it says sequence, okay, and you are finding a term, you're going to use the first one. Okay? So, this time, I know some more information. I know that a to the 9th is 72. I know that, or I'm looking for my first term. I have information about the 9th term, so I can use n as 9. And I know my common difference is 5. Good? Plug and chug in the formula. So I have 72 is equal to the first term, which is what I'm looking for, plus my one term that I know, and the common difference of 5. Good? All right, so let's simplify. And so 72 is going to be equal to the first term plus 40. Right? So my first term is 32. Good? Do you guys feel okay about the sequences in this formula? Are you getting better about it? Yes? No? Should we do some more? Yes? One more? No? You got it? Yeah, I don't know. Let's see. Let's skip the 4 because 3 is using the sequence, so we're still going to use the first formula. This time we're just looking for D. And so we would plug in everything that we're looking for. So 163 is equal to 3 plus n minus 1. And then my common difference between these two. Are you good on that? All right, then let's find some sums. Okay, so now I'm going to use the second because I just want to find the sum, so I have the s to the n, and I know that n's 13, so I'm finding the sum of the first 13 terms. So 13 divided by 2 times my first term and my 13th term. So 16 plus 98. Good? Easy peasy? So when I combine those, I'm going to get 114. And let's plug and chug. So 13 divided by 2 times 114. So that means that the sum of the 13 terms is 741. Good? All right, one more and then we'll put them into real life use. So, I'm finding the sum for the first 8 terms. That means my n is 8. Would you agree? What, are you guys shaking your heads? You're just so quiet. So, s to the 8th is equal to 8 over 2. What's my a1? Kaylee, what's A1? Yep. And I want to do A to the 8th. Do I know what A to the 8th is? I know 1, 2, 3, 4, 5. How can I find A to the 8th? Yep, use the other formula, perfect. So I'm going to find A to the 8th is equal to A1, which is 2, plus my 8 minus 1, and my common difference is 3. So 2 plus 7 times 3 is 21 and 2, so that's 23. All right, let's simplify. I got 4 and 2 plus 23 is 25. Whoops, I wrote my... So the sum of all 8 terms is going to be 100. Good? Okay, so the next page in your packet says day 3, but remember how I'm an idiot and can't copy pages in the right order? You flip to the back side of that, because 7 and 8 actually go with this, and then your practice tonight are these 4 problems, and there are your answers, okay? But let's put these to use, okay? So, this is why we care about these things, all right? So, the first year, I got tuition out of the local college is $4,000, okay? So, you guys, let's say you're, I don't know, sisters, whatever, in the 10th year, they're going to be going to college in 10 years, right? So we want to figure out how much are we going to need to have your sister or whoever go to college, all right? So is that something that's going to end up being using a sequence, or is that going to be a sum? Chase, what do you think? Some? Okay. Anybody else have any other opinion? Well, let's think about what we know, okay? We know that the first year tuition's $4,000. Would you agree with that? Okay? And we know that we're looking for the 10th year. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? We're looking for the number in that position. Would you agree with that? Okay? So couldn't we use our sequence, because that'll give us a specific term number? Would you agree with that? Does everybody see that? So, because my first position is 4,000, I'm going to look for the 10th term. So I know my n is 10. And what's my common difference going to be? What is it increasing every year? Huh? Yeah, it's going up 600 every year. So that means I can say, hey, a to the 10 is going to be the 4,000 for the first year plus my 10 minus 1 times the 600. Does that make sense? All right, so 4,000 plus 9 times 600 is going to give me 5,400. So in 10 years, the cost is going to go from 4,000 to 9,400. So if this is a story problem where it's looking for like a specific number for a point, you want to use this sequence because that's your list. But for the next one, we have stack of telephone poles, has 30 in the bottom row, 29 in the next row, and so on, with one pole on the top row. How many poles are in the stack? This time I'm looking for a total, right? So that means I need to use the sum. So I need n. How many rows am I going to have? If I have 30 down here and it decreases by 1 each time, how many rows am I going to have from there to there? 30. Okay? And my first one is 30. Agreed? So I'm looking for the 30th term. My first row is 30. My last row is 1. So I get 15 times 31, which gives me 465 logs total. Make sense? Those are why those are helpful. All right, just these 4 for tonight, okay?